because you do not have decimals. No decimals. But if it is a continuous random variable, then you can actually join with a line. Suppose I said that the length of that section is 3 feet. I can represent 3 feet from 0 to 3. And I can actually join them with a straight line. I can join with a straight line, showing that even though it is 3 feet, it can contain decimals, 2.5. Okay, 3 is an integer. But what if I say 2.5 feet? 2.5 feet still fits into continuous because it is measurable. Measurable. Okay, I want you to associate continuous with measurable, discrete with random. Discrete is countable, continuous, measurable, discrete, countable. Okay, I think that's enough. So when you're going to do your homework for tonight, you will notice that you'll be told to plot discrete variables and plot random variables. Okay, this is an example. These are examples. Which ones are discrete? I would like you to talk this time. I would like you to say something. A group of students plan to purchase a 16-ounce bag of M&M and record data on the content. For each of the following variables, state whether it is discrete or continuous. Discrete or continuous. Remember the new words today. Even though it may not be new to you, but they are the new words for 6.1. State values for variable. The mass or weight. Can the weight of M&M be decimal, contain decimal? Somebody, yes or no? Why? Weight. If you weigh M&M, can it be 3.5 grams or milligrams? Can it be 3 milligrams? Can it have decimals? Can it be continuous? If you don't answer, I'll let you answer it today, but by the time you do your homework. Number of pieces of candy in a bag. If you're counting the number will be discrete. If you're measuring diameter of each piece of candy, diameter is continuous because it's measurable. Number of distinct colors of M&M in a bag. All right. So we will actually be doing a probability with it today, like we did in Unit 2. The probability distribution of a discrete random variable X provides the possible values of the random variable and their corresponding probabilities. A probability distribution can be in the form of a table, a graph, or a formula. A probability distribution can be let's make one so that you know. Let's make one. Suppose I have 0 to 5 and I have 3. I'm making a table here. 6 to 9 or 6 to 10. And I have 4, 11 to 20. I have this is 10. I have 2, 21 to 30. I'm just making a table. So this gives me 9. This is 1. Okay, and I call this class. I call this frequency. If I add all the frequencies I have, total frequency is 10. Yes, 10 here. So total frequency is 10. Sigma frequency. I can be told to convert. I told you before. I told you that the frequency distribution will be called probability distribution. I can be told to convert this frequency distribution to probability distribution. Convert this frequency distribution to probability distribution. For each probability, all I'm going to do is find relative frequency, because we said that probability is the same as relative frequency. Okay, so we talked about it in Unit 2. So somebody give me the probability of the second class. What is the probability that I am looking for something and I found it in the second class? Anybody? Somebody says something? The probability is the frequency over total frequency. Frequency over total frequency. Right here is frequency over total frequency. Frequency over total frequency. That is called relative frequency. And that is also called proportion. And now we are calling it probability. Now that we are done with this, we have what is called the probability distribution. Remember when we were in Unit 2, we called it frequency distribution. Now we converted frequency distribution to probability distribution today. Therefore, we can actually convert a frequency distribution to a probability distribution, and we'll call it a probability distribution. The most important thing is that when we finish the conversion, the sum of all the probabilities must be equal to 1. Everybody look. The sum of all the probabilities must be equal to 1. And none of the probabilities will be outside 0 and 1. Probability cannot be less than 1. Probability cannot be greater than 1. If all these properties are observed, then our distribution is a probability distribution. If the sum of all the probabilities is 1 and none of the probabilities is negative and none is greater than 1, then our distribution is a probability distribution. Then our distribution is a probability distribution. So, any question with this? This is actually in one of our questions right now. I think I'll go there straight so that, all right. Okay, you can, suppose you toss a die. Let's just, let's get another one that is quicker so that we can go to, let's go to the one that's quicker. We will use a calculator to find the mean, standard deviation. If you're told to find the mean by hand, the mean of a discrete random variable, it is by formula, each random variable multiplied by the, each random variable multiplied by the probability by formula. But anyway, you can still do one variable start and find the the mean, the standard deviation, and the variance. Okay, so I will soon do an example. And so you know you can can actually do that. The mean is actually the mean again. So you can be told to find the mean of a probability distribution. It's not a frequency distribution now. If you're told to find the mean is still add all the random variables and divide by the sum. Okay. So anyway, excuse me. Excuse me. The standard deviation of a variable is this, but you can use the calculator and do one variable stat. You don't have to memorize all these formula, but I give you a formula sheet. In Unit 3, you can see that there is a formula sheet that you will be given on the test there, but you don't have to use the formula sheet. So let me go back and get, I think the introduction is here and it's over. Let's quickly go to practice test. So let's go to practice test. Practice test 3. This is practice test 3. We have already said important things, very many important things. So there are things we can do. So let's go. I'm not going to do all the practice tests. You can actually start from section 6.1. But what I'm going to do, first of all, is in a probability distribution in the right here, the random variable x, this one, represents the number of baseball players in the game over the course of season. Completes pass A to F. Okay. So the first thing you want to do before you start completing anything is you sum all the probabilities. Is the sum of all the probabilities equal to 1? Before you start doing any arithmetic or calculations in probability distribution, you want to check the two rules, two important rules of probability. Is the probability equal to 1? Is there any negatives? Does it contain any negatives? Does it contain any negatives? Okay, I'm just going to eyeball the right-hand side. There is no negative. The sum of all the probabilities is equal to 1. Therefore, but by the way, I haven't added it. So let me not say it, the sum. So let me get my calculator. Because I don't want to assume that the sum is 1. So I'm going to put the calculator up and verify that the sum is 1. I need TI-84. Let me get TI-84. So I want to, by the way, can you see someone tell me, can you see my calculator? Can you see my calculator? Somebody say yes, open or unmute, say yes or no, that way. Yes or no, can you see my calculator?
Yes, ma'am.
Huh? Okay. Now, what I want to check is I am given a probability distribution and I'm told to do arithmetic with it. And because I already did probability in chapter in unit 2, I was told that the two important rules of probability is that the sum of all the probabilities must be 1 and there should be no negatives. So I want to sum all of them. So let me sum. You can sum any way you like, but I want to, the way I sum it, I'm going to put it on in my calculator. So I will put the numbers 0.1677, 1677, enter. Point 3366, enter. Point 28, okay, 2833, enter. The third one, actually fourth one is 0.1488, 0.1488, enter. 0.0382, enter. 0.0254, enter. Okay, so I have entered 6 of them, and my calculator is asking me for the 7th one. When I finish entering, I'll check and see if it's right. Did I enter everything? Is there any number that does not look like what is here? Okay, then I'm going to sum. I can sum it in so many ways. I can just do one variable start, and the sum will be there. I'm not doing. Okay, let me do one variable start. I'm not supposed to, but let me do. Go to start, arrow to calc. I'm going to do one variable start of L1. This is the quickest way of looking for the sum, because I'm not. So the sum of all the variables is 1. Do you see? Everybody see? Are you looking? Instead of adding it and making a mistake, I can do a one variable start, and my calculator gives me the sum. That is the quickest way for you to find the sum, because the data can also be up to 30. If there are 30 of them and you're doing it by hand, you can make mistakes. And by the way, I'm so proud of you. Your class is a much different class. Nobody made less than 70 again in test number 2. By the way, nobody made less than 70 in that class. That test number 2. That is wonderful. I usually do have 40, 30% and stuff like that. And I have up to 10 people make 100. If you make more than 100, well, I cannot put more than 100 in Blackboard. But when I give you your paper on Thursday, you notice that some of you made more than 100. The paper was graded at 105 again. That was good. Kudos to a lot of you. Worked so hard. I'm so proud of this class. But anyway, I want you to look. I told you that knowing how to do one variable start can solve a lot of problems for you. If we want to find the total of all the random variables, you see, you can do one variable start, and it gives it to you. So you will know whether it obeys the probability rule or not. If it does not, no, you cannot do any arithmetic. If it does not obey the probability rule, you are not allowed to do any arithmetic. Okay, by the way, I'm going to take a picture of those who are in class now, and at the end of class, I will take a picture again, because we are, okay, somebody has a question. Yes, let me see, what's the question? Okay, it's here too, will not pull up. Return is here too. It will not pull up. Taylor Boland is here too, but computer died. Oh, okay. I'm going to make sure I take the picture of these comments so that I'll mark you present. I want to make sure that I'll mark you present. Everybody that, even if your computer is not helping. All right. So now I am going to take a picture of everybody that is still here too. All right. No connect. Okay. And then I'm going to go back to my calculator. And if I'm told to find the mean, because you'll be told to find the mean of the probability distribution. Yes, you'll be told to find the mean. The mean is 0.167 to 3 decimal places. The sum of all the random variables is 1. The standard deviation of the probability distribution is 0.1259. You can be told to leave it to 5 decimal places. And so you can be told to answer any question. If you're told to find the maximum number, yes, you'll be told to find the maximum number. Of course, you know it has to be decimal. The maximum is 0.3366. The minimum is 0.0254. So you can be told to find all the things you used to find. The only difference is that this is a probability distribution. It is a probability distribution. Okay. All right. So we keep on going. So now you know that you can also do probability distribution in chapter 6. You'll be told to do probability distribution. Next class, we shall be talking about binomial distribution. Binomial distribution. Okay, so let's go back to the notes. Let's go back to those notes. Okay, verify that this is a discrete probability distribution. We're answering the questions here now. Verify. This is the kind of question you have in the some of these questions are already in the test. Verify that this is a discrete probability distribution. This is a discrete probability distribution because none of the numbers is negative, or it is between 0 and 1, 0 and 1, and none is negative. There are so many ways you can write it. Okay. It is a probability distribution because none of them is negative. And the probability of each and every one of them is between 0 and 1. None of the probabilities is greater than 1. Draw a graph of the probability distribution. So if you are told to draw a graph of the probability distribution, of course you know that you cannot draw a histogram. You have to draw a bar graph. You have to draw a bar graph. So in a probability distribution, you draw bars. And a probability distribution graph has probability in y-axis and random variables in x-axis. The probability distribution has probability, just like frequency or relative frequency. So I hope you remember that this is relative frequency. Relative frequency in y-axis and random variables in x-axis. Okay. Now you can draw that. By the way, you ask yourself, what is the highest probability? The highest probability is 0.3366. The lowest is 0.0254. Okay, now you can draw your graph. You can start from 0.0, okay, 0.1, 0.2. There's no way you can accommodate all the 4 decimal places. And then when x is 0, you plot the points one by one. Plot the points one by one. All right. Okay. Describe the shape of the distribution. Describe the shape. When you finish, I'm going to let you do this one. When you finish, describe the shape. It says compute the mean and interpret the mean. We just computed the mean. The mean of the probability distribution, by the way, it is n times p. N times p, if you are told to describe it, it is the number times probability, 1 by 1. But anyway, we have it from our one variable stats. So the probability, the mean is the average. Okay, and then you put your answer here. Compute the standard deviation, which we just did. Remember, we did it by one variable stat. One variable stat. All right. And then what is the probability that a randomly selected game they got by? What is the probability that, okay, so you can, let's go there so you can see what we're saying. What is the probability that you close your eyes and found 2? The probability is 0.2833 in decimal. You can be told to, you can leave this answer in percent. So the probability is 28.33%. What is the probability that you got 5? The probability is 2.54%. All right. So I think we actually, I don't think we looked at number 1. Okay, what is a random variable? But that could be questioned like that. Okay. A random variable, this is not right. A random variable is a numerical measure having either finite or countable number values of outcome in a probability experiment. Okay, so first of all, you have to read that again and then choose an answer. This practice test has answers. Let me show you. So you know that you don't have to do it. You don't have to submit it because already it has the solutions. You see? It has solutions here. So you don't need to complete it. You don't need to submit it. It's just for your information. It's just for your practice. Just for your practice. Okay, and then somebody's trying to see if you remember the properties of probability. What are the 2 requirements for a discrete probability distribution? If a probability is a discrete probability distribution, the sum of all the probabilities must be 1. Be careful. It is not A, because S said 0 is less than, probability is less than 1. This is not the answer, because actually the correct answer is C. C says probability cannot be less than 0, cannot be less than 0. Probability of a variable cannot be greater than 1. And probability must be between 0 and 1. Must be between 0 and 1. Okay, and this has 3, 1, 2, 3. You can explain this number C in 3 different ways. Probability of an event cannot be less than 0. Probability of an event cannot be greater than 1. The sum of all the probabilities must be equal to 1. Must be equal to 1. And the probability must be on the line 0 to 1. 0 to 1. So probability must be on this line. And because it can be on that line, your answer will be continuous. Answer will be continuous. All right. I'm just going to get one and give you time to answer the question. And I'm not giving you one that is binomial. So I'm not giving you binomial. Binomial will be next class. So today we're just talking about probability distribution. We're not talking about binomial. Binomial will be next class. And so binomial will be next class. All right. So that is that's our probability, and that is our introduction on probability. I think we have